Hello, I am Natasha Yaluru and I'm a field metabolomic scientist for Metabolon's international business team. Today I would like to go over a case study that demonstrates the impact of a probiotic supplementation on the metabolism of older women with low bone mineral density and to explain how metabolism is linked to improved bone health. Osteoporosis is a very common disease that predominantly affects older adults with a much higher incidence rate among women. This disease is characterized by a gradual loss of bone density and strength, which increases the risk of fractures and other complications. Emerging research suggests that the gut microbiota plays a critical role in regulating bone metabolism, which in turn could impact overall bone health. Several studies have explored this link between the gut microbiome and bone health, highlighting the potential for novel interventions and treatments for conditions such as osteoporosis. One such example is a supplementation of a probiotic strain, Lactobacillus reuteri, which has been shown to reduce bone loss and to increase bone density in mouse models with estrogen deficiency. The authors of the study we're going over today demonstrated in previous work that administration of Lactobacillus reuteri resulted in a significant reduction of bone loss, up to 50%, in postmenopausal women with low bone mineral density. These findings offer very promising insights into the potential for using Lactobacillus reuteri as a therapeutic intervention for osteoporosis, as well as other bone-related conditions. Additional studies conducted on mouse models have suggested that probiotic supplementation could enhance the production of short-chain fatty acids in the gut, but the specific mechanisms underlying the effects of different types of probiotics on human bone metabolism remain unclear. And to address this gap in knowledge, the study that we're talking about today represents one of the first attempts to directly investigate changes in metabolomics and examine their impact on human bone metabolism following a probiotic supplementation. In a placebo-controlled study, 68 elderly women with osteopenia were recruited. 32 women were randomized to treatment with the probiotic and 36 to the placebo group. The researchers established an additional cross-sectional case-controlled study with 240 elderly women, including 120 women with high bone mineral density and 120 with extremely low bone mineral density. This group received no intervention and was only used to confirm the associations between bone mineral density and the identified metabolites between Lactobacillus reuteri supplementation. The placebo control study was longitudinal in design, with serum samples collected at baseline, at 3, 6, and 12 months of treatment with the probiotic. 269 serum samples were analyzed using Metabolon's Global Discovery Panel, resulting in 993 metabolites being used for downstream analysis. At baseline, the Lactobacillus reuteri and placebo groups exhibited similar metabolic profiles as well as other clinical parameters. However, the metabolic profiles differed between the two groups during the follow-up period, suggesting a significant effect of treatment on the metabolome. The impact of the probiotic supplementation on metabolic responses was further investigated using multivariate statistical modeling. The score plots here indicate a distinct separation of the Lactobacillus reuteri and placebo groups in response to treatment at 3, 6, and 12 months. Two metabolites specifically were significantly different at all 3 time points. Firstly, butyryl carnitine, which is related to fatty acid metabolism and is also linked to butyrate transport. And butyrate is, of course, a short-chain fatty acid that is produced by the gut microbiota, highlighting a functional effect of the probiotic supplementation on the metabolism and bone health. The second metabolite, 1-methyl-4-imidazole acetate, which is involved in histidine metabolism. And histidine is an essential amino acid which plays a crucial role in bone health by being involved in collagen synthesis, which is a major component of bone tissue, and that it's also been shown to prevent the formation of advanced glycation end products, which are of course known to contribute to bone loss and osteoporosis. This molecule is also a precursor to histamine and carnosine, which are very important in bone resorption and remodeling. The researchers also found that at 13 and 9 metabolites were correlated with total TBA volumetric bone mineral density at baseline and 12 months respectively. Total TBA volumetric bone mineral density is the density of minerals in the tibia bone, which reflects overall bone health and strength. Now, interestingly, this molecule, isovalerial carnitine, which is a branched chain amino acid derivative, was positively correlated with total TBA volumetric bone mineral density at both baseline and 12 months, suggesting it may be a potential biomarker for bone loss. By using Metabolomics to examine changes that result from Lactobacillus reuteri supplementation in elderly women with low bone mineral density, the researchers revealed a number of key metabolites that could be used as biomarkers for future treatments. This study identified a global shift in the metabolic status of the treated women over 1 year of Lactobacillus reuteri supplementation. And this probiotic treatment induced shifts in multiple metabolic pathways, including amino acids, peptides, and lipid metabolism, as well as a significant increase in butyryl carnitine, which was, of course, of particular significance to these patients. This increase in butyryl carnitine suggests the involvement of butyrate signaling in bone metabolism, and indeed butyrate supplementation has been shown in the past to increase bone mass in mice and to prevent bone loss. So the increase in this metabolite during the whole treatment period may explain the effect of Lactobacillus reuteri in reducing bone loss observed in an earlier study from the same group. Analysis of the metabolomic differences in the case and control population of elderly women with severe osteoporosis or high bone mineral density confirmed the associations between bone mineral density and the identified metabolites influenced by Lactobacillus reuteri supplementation. And the amino acids, especially branched chain amino acids, showed association with Lactobacillus reuteri treatment and with low bone mineral density in older women. And many of these amino acids serve as potential therapeutic targets. It is possible that branched chain amino acids could stimulate osteoblast differentiation and to improve bone metabolism by directly acting on mTORC1, and also to improve bone density by indirectly regulating mTORC1, which plays a critical role in T cell regulation and insulin signaling that affects bone homeostasis. While future studies are of course needed to pinpoint the exact mechanisms leading to a reduction in bone loss, this study's use of metabolomics identified several leading candidates that link changes in the gut microbiota to changes in metabolomics that affect bone metabolism in aging women. We hope that you found this study informative. If you'd like to learn more about the topic or have any questions, please don't hesitate to visit our website, which is a great resource for additional information. And our team is always available to answer any questions you may have. Thank you very much for watching, and we look forward to hearing from you.